Major objective of this webinar is to help students who completed their high school to smoothly adapt to higher secondary school level chemistry. I used to get feedback from students when they enter about the difficulties that they face in understanding the following topics. The topics are atomic structure, thermodynamics, chemical equilibrium, electrochemistry, structure of organic compounds. Out of these topics, atomic structure and how to learn atomic structure in an interesting way was discussed in the last webinar. This webinar you can watch in GrannyMaster website. Remaining 4 topics: thermodynamics, chemical equilibrium, electrochemistry, structure of organic compounds, we will be studying in this webinar. First topic is electrochemistry. As the name suggests, electrochemistry deals with 2 types of reactions. One, chemical reactions leads to electricity. For example, in battery, chemical reactions occur and leads to electricity. Second one, electricity leads to chemical reactions. For example, if we pass electricity to water, water will be decomposed into hydrogen and oxygen. So 2 types of electrochemical reactions. One, due to chemical reactions, electricity is being formed. The second one, due to the supply of electricity, chemical reactions will happen. Now, a question: is it really difficult to understand electrochemistry? Sometimes students say that, okay, it is difficult to understand because of some terms such as electrode potential, anode, cathode, electron flow, electrolyte, electrolysis. These terms actually give some kind of confusion to the students. At this end of this lecture, at this end of this webinar, I hope you will be having a clear-cut idea about these things. To answer this question, is it really difficult to understand? We can look into the history of electrochemistry and electricity and come up with how this branch of science expanded. In 600 BC itself, people were having idea about static electricity. Like if you are rubbing 2 objects, static electricity will be generated. This information people were having, that idea before 2,400 years back itself. But this static electricity is not electric current, because the charges created during that rubbing, they won't move from one place to another place. So we won't consider it as an electric current. So when that's more studies about electric current started, it started with the experiment done by Benjamin Franklin. In 1752, Benjamin Franklin and his son, they conducted an experiment. This experiment is a kite experiment. In this experiment, a kite with a pointed conducting wire attached to the apex of the kite is flown near thunder clouds to collect electricity from air and conduct it down the wet kite string to the ground. The experiment purpose was to uncover the unknown facts that the nature of lightning and electricity, and with further experiments on the ground to demonstrate the lightning and electricity were the results of same phenomenon. Very dangerous experiment actually they conducted, but luckily they were safe to conduct that experiment, and they concluded that both lightning and electricity were the results of same phenomenon. Very important point. Till that time, nobody was having any idea about what is this lightning. They knew that it is a form of energy because, during lightning, sometimes fire will occur, sometimes trees will burn, right? So they knew that it's a form of energy. But whether the lightning and the electricity, they were of same phenomenon, that idea people were not having before that. So what is the takeaway point from this experiment? Both lightning and electricity are sources of energy, and these energy forms are due to the result of same phenomenon. What is that phenomenon? Now we know that the phenomenon is electric current, which is flow of electrons. In 1791, another interesting experiment done by Louis Galvani. He discovered the term, or he discovered the phenomena bioelectromagnetics. So he was a doctor, he was doing experiment with the frogs. So what he had done, he connected a frog's leg to its spinal cord using 2 different pieces of metal. He used iron and bronze and iron and silver, two different metals he used. Upon touching these metals to complete the circuit, then he found that the frog's leg twitched means moved. When he connected the leg of the frog and the spinal cord of the frog using two different metals, he found that the legs of the frog, it twitched or moved. Galvani concluded that that movement is due to electricity. And he found that the electricity is coming from the frog. So he concluded that electricity was intrinsic to the frog and the metal simply acted as a conduit. So he thought that the electricity is produced by the frog and that electricity flow or electricity moved through the metals that he connected to the frog. And he called that electricity which came from the frog as bioelectricity. So he thought that living beings produces electricity and he named that electricity as bioelectricity. But later, the scientist Alessandro Volta, he found that this experiment is not correct. He identified that there is a fault in Galvani's experiment. He checked that by connecting the metal wire only whether he can make electricity. So he repeated the experiment. He didn't use the frog at all. Alessandro Volta repeated the experiment. He didn't use the frog. He just connected different metals arranged in a different way. Just metals only. He tried to connect. He found that without the frog also, the electricity can be produced by connecting different metals in a particular way. And he concluded that after several experiments with the different metals and different wires, he concluded his argument that if you connect two different metals in a particular way, we will be able to generate electricity. We actually don't require any animal or any bird to generate that electricity. So he thought, from where that electricity is being generated by connecting two different metals, how the energy is being generated. And he found that energy may be due to a chemical reaction, or the electricity is produced due to a chemical reaction. And he made his first battery. So we all are using batteries now. The first battery is being made by Alessandro Volta. What he has done, he conducted a chemical reaction with the help of metals to produce electricity. And using this technique, he made his first battery, and that battery name was voltaic pile. This made in 1800s, in the first years of 1800s. Why the name voltaic pile? The Volta term came from his name, Alessandro Volta. Pile means you can see so many batteries are connected over one another. So it's a pile of batteries. So he gave the name voltaic pile. So in this picture, you can see the voltaic pile in which stacking of different discs of metals. Mainly he used copper and zinc separated by cloth. So you can see one will be, you can see in this figure, one zinc, then copper, then zinc, copper, like that. He stacked this copper and zinc disc alternatively. And in between, you can see some cloth between them. That cloth was actually dipped in brine solution, sodium chloride solution. So the cloth in between the zinc and the copper was dipped in brine solution. Brine solution means sodium chloride solution. And he found that electricity is being produced when he piled up all these zinc and copper discs, which is connected between that. We can say that, okay, the electrolyte. The oldest form of electrolyte was this cloth which dipped in brine solution. Then 1830, Sir Humphrey, he made a giant battery. See, giant battery by connecting so many small batteries. 2,000 pairs of plates, 2,000 zinc plates and 2,000 copper plates he connected in series, and he made one of the biggest battery at that time. And the size of the battery is like 889 square feet. So it is the size of a 1-bedroom house. That much big the battery was. What is the importance of battery? Now we know that battery is being used in most of the application that we are using now, even in mobile phone, laptops, right? Even now in car, electric cars are now quite famous. All these things are made from chemical reactions. Chemical reactions leads to electricity. Chemical reactions leads to electricity. And what is advantages of chemical reactions conversion to electricity? Then the battery will be a portable battery. You can take that battery wherever you go, like mobile phone, right? Battery, wherever you want to take, you can take it. Inside the battery, chemical reactions will happen and you will be getting electricity. That is the beauty of this first battery. And later, we know that now we have n number of different types of battery, which makes the life of us very easy. Michael Faraday, some people are saying that he's the father of electricity. Some people have said that it is another person in 1500 to produce electricity. But I still call Michael Faraday as the father of electricity. Why we call him as the father of electricity is because he invented the dynamo. Dynamo, the present name of dynamo is electrical generator. Dynamo was developed to produce electricity through Faraday's law. Through Faraday's law, he produced electricity. Then why he is not the first person who discovered electricity or who made the electricity? Then still why we call him as father of electricity? It's because this discovery revolutionized the massive production of electricity. Now we know that we require massive amount of electricity. For example, in your house, you are getting electricity. And we know that the electricity that you are getting not through battery, right? Not through battery. The battery we will be using to operate our mobile phone, laptops, those things. The electricity that we are getting in our house to operate our TV, fan, air conditioner, fridge, washing machine, all these things are not from battery. Rather, it is produced somewhere, maybe in a hydroelectric power station, or in a nuclear power station, or in a thermal power station. From there, we are getting electricity, and that electricity will be passed to us, and we can use it at our home. How electricity is being produced there? That is with the help of electrical generator. The first form of electrical generator was dynamo, that was invented by Michael Faraday. So Michael Faraday started the massive production of electricity, or